Okay, thank you very much. My name is Ray. I'm from University of Calgary, and my talk is going to be on trusting outsourced computations. And in particular, we are going to look at using a smart contract. So it's a kind of application of blockchain in providing trust in the result of outsourcing. So first, it's to motivate this topic. Let's look at where we are today. We have a lot of data. This data is generated by sensors that are attached to us, or they are in our environments. They do measurements all the time. When we go on the internet, there are sensors that measure the traffic, the whole infrastructure that is around us. They are equipped with sensors that generate data and collect data. And then we have a lot of computation that are applied to this data. And then what we are getting from all of this is a very much better personalized services. We will have automation in our smart home. We have devices that work according to our preferences. And so we are living in a much more comfortable world in many ways, because we have all these data generated and processed to provide these nice things. And of course, I'm leaving aside all the privacy issues that is related to this data. At the moment, my main focus is on really making this data to make our lives better. So, but the question is that now all of this data and all this computation that are required for providing these nice services, so how this has to be consumed by our small clients that we are carrying with ourselves, on our computer or on a mobile phone, and these are weak clients, so they cannot handle all these huge amount of data and hold the computation that is required on this data. And so that is the problem of outsourcing. So this is what we have learned over time, that our devices by themselves, they are not capable of storing data, holding data, and then processing them. So what in general, we have layered clouds. So we have a smaller cloud, we call them fogs, that are closer to our end devices, and then there can be many of these fog computing environment, and they're dealing with a higher level cloud. And so in both cases, we have these storages that store some data, and then the computation, and then the ecosystem of all of these clouds and fogs give us what we are having on our devices. We talk to Alexa, and we talk to different Siri and things like this. So this is the result of all this computation that is happening outside our devices. So it's different setting for outsourcing also comes when we have this a distributed computation. We have a huge computation. We break them into small parts and send them to different clients. And these are usually, they can be volunteer clients, and they can work to let me get the pointer. So to these clients that volunteer to participate in the computation, give us partial result, and we put them together and get the final result. So this is the kind of project that started in Berkeley in late 90s. This is the SETI at home, the search for extraterrestrial intelligence at home. So all these computing nodes, volunteer nodes around the world participated in this process and helping doing part computation toward this big goal of finding extraterrestrial intelligence. So, but this infrastructure for distributed computing has found a lot more application. So for protein folding, for vaccine development, the latest one in the case of COVID-19, that we have this distributed computation used for using extra cycle on computers do this, to do large computation. So this is also a kind of outsourcing. And I think so these examples usually comes with these volunteer nodes, but we also have this vision of the case that we have a global computer, supercomputer that that is composed of all extra cycles that people have on their computers and use cycles. And what we are going to do, we are going to pay them and get those rented their extra cycle on their computer toward our bigger goal. So, and that's also, you can see, is a very noble vision. People get paid for, similar to Airbnb. So now you're renting your extra cycle on the computer. So all of them are part of this outsourcing that is happening all the time. And now in all of these cases, the question is that from the client viewpoint is that, okay, so how do we know that the result that we get is what we are expecting, what should happen? So how can we trust that the y is actually equal to f of x that we wanted to compute? Okay, so now if we fast forward to the time of blockchain, and so one of the things that blockchain gave us, so this is the general form of a blockchain, these transactions that are all verified by the network of all these computers that are part of the blockchain, all of them verifying these transactions, forming these blocks that are appended to the blockchain. But so what we can see is that in this case, we effectively have this consensus computer that every transaction is verified by all these nodes in the blockchain. And that is where the concept of a smart contracts comes in. So a smart contract is now a program that we can run in blockchains like Ethereum. So there are immutable, transparent, trusted program. And we call it trusted because it is run by all these computers and all of them agreed on the result of computation. In that sense, we can trust it. So you can see that. So I think this is an extremely attractive feature of blockchain that enable us to have this trusted program that we cannot have on any easily on any other computer. So there are other methods of obtaining trusted computation, but they're all subject to all kinds of attacks. In this case, we have a really nice opportunity to have trusted computation. So it seems that our outsourcing problem is solved. So now we can outsource our program. So F and X, they can go, we can send it to a smart contract and run it on the blockchain. And because it's a trusted computation, we have solved the problem, which theoretically is yes, but in practice, it's a completely impossible answer to give to this question because of the size of the computation and the enormity of resources that is required for such a thing. So if each instruction of a big program is run by every computer around the world, this is not a solution that anyone would accept. And so that's not acceptable. So that is what I'm going to do in this talk, to say a bit about what is outsourced computation, what are the models of outsourced computation, what we know about them, and then use a particular model, which is replication-based, which is somehow similar to what we saw, many nodes computing the same thing, but now using a smart contract in a layer 2 solution. So we are not going to send our computation to the whole blockchain, but we use a smart contract as to manage our computation and see what are the challenges that exist using this solution, this approach. And then some concluding remarks. So I think the main takeaway from my talk is that even if you have a perfectly secure protocol that we have proven its security cryptographically or using game-based approaches, when you take it to when you combine it with a smart contract, which you think is a trusted computation, this combination may not be secure, and it requires redesign. In many cases, requires redesign of the protocol. So this again, we have seen this before, but again, this is also an example that two individually secure systems, when they put together, they may not be secure. Okay, so with this introduction, I think let's look at what this outsourcing is. This is the abstract model of an outsourcing. You have a vClient, you have a cloud, and so or server, cloud, whatever you call it. The client sends a function and input that it wants to be computed, the function to be computed on, and the cloud will send back this result. And then the question is that how can the client be sure that this is the same result that it wanted without redoing the computation? Of course, we can always say client should do the computation itself. So, but that's not the solution here because of all the reasons that we said, especially the size of the client and the size of computation, etc. So this problem of being able to verify a claim of a server is something that is studied in cryptography for a long time. So it goes back to mid-80s by Babai, Goldwasser, the seminal work of Goldwasser et al. So they talked about this, introduced this concept of interactive proof. So we have a prover that makes a claim. So for example, it says that I know the value of X, which is a secret. I'm not going to tell you, but I know the value of secret. And now the verifier wants this to be proved, this claim to be proved. And then there is a sequence of challenge and response between the verifier and the prover. And during this, because of this interaction, then verifier will be convinced that the prover knows this X, this secret, or the statement that prover has made without knowing details of the thing. So that is where the concept of interactive, the beautiful concept of interactive proof comes in. But these are, of course, interactive protocols, many rounds, and they're not something, these are theoretically elegant, very beautiful, but not something that we can use in practice. Now, later, with the rise of cloud computing and the importance of this obtaining confidence about the result of computation, there's been a lot of work on modeling to adapt this model to the case of a cloud computing without removing this interaction. So now the client, the verifier sends the result, and then, but this encoding is not going to be just F and X, it's going to be a much more complex encoding of the input and the function. And now the prover will has to produce an answer that enables the verifier to verify not only that this computation has been performed correctly. So this has generated a lot of very fundamental research, beautiful research, both on the theory side and also on the side of becoming more practical. But in all cases, what you see is that these are the solutions that for both of these groups, in practice, they become, when they're purely cryptographic and interaction with one server, they become quite inefficient, and they are also rigid. If you want to change a parameter, you have to do a lot of work in your implementation. They're fragile. One bit change can change in the implementation, can affect the result of computation. And this encoding of the input is a very complex process that the vClient can hardly manage. So this seems that, that from pure cryptographic viewpoint, with a single server, we don't have much lag. Now, there is a natural approach to verifying or obtaining confidence in the result of computation, and that is by replication. It's a very natural concept. So instead of sending the computation to one server, we are going to send our computation to multiple servers. The same computation goes to multiple independent servers, and then when we see their result, we compare them, and if they are all the same, we are confident that it's the same value that we want. And if they are not the same, then now we have to design protocols that give us this confidence. So we have to have these referee or judge protocol that allow us to find what the correct result is. So now you can see that this model is very nicely adaptable to a smart contract setting. So now, instead of having the client sending this thing, we can give this task to a smart contract. So the problem giver sends the problem that it wants to be solved to the smart contract, and the smart contract actually distributed to a number of servers. The nice thing about a smart contract here, we are introducing a trusted intermediary. So this trusted intermediary also provides the support for payments to these clouds for the work that they have done, and also ensures that if for a mischievous problems giver, then it's not going, these clouds, the servers are not going to be disadvantaged. So it's really a nice way of managing this whole process. And it seems that it's quite practical because this is just directly FX. There is no complex encoding. You just send the computation directly to these servers. So it's a very nice solution here. And in fact, there is a real life system that works like this. So TrueBit is exactly a company that provides this service. It's a incentivized layer 2 system. It uses a smart contract to interact with the nodes that are volunteering to participate in the computation, and also it manages the payments. It's an incentivized system in the sense that it incentivizes participants to behave correctly. So you can see it's a 2-layer system. So here, this is off-chain. All the computation are done by the servers off-chain, and the on-chain is all the management of the incentive layers and payments. All of them is on-chain, which is much smaller computation. So this system does exist. And there is a white paper, there is security argument, but this is again one of those systems that relies on paying rewards and bonuses and penalizes bad behavior, but it's a kind of, there is no security proof for this. So that is the question, that can we go toward a layer 2 solution that has provable security? So I think that is the question that we would like to explore. And so if you now step back and look at the literature that exists in the traditional security, cryptography security, we have these 2 models. So there is a multi-server case, so a problem giver outsourcing to 2 computers, to 2 computing nodes. There is this work by Canetti et al. In CCS, which is a flagship security conference. So they've introduced a protocol which guarantees that if you have, so when we look at multiple servers, the smallest number can be 2. So they show that if you have 2, if you outsource if the computation is outsourced to 2 clouds, if one of them is honest, so of course you get the 2 results that come back, they are incorrect. They're not going to match because one of them is malicious, one of them is honest. So they're done. But the question is that how can the problem giver decide correctly without doing a lot of computation? So we want to minimize the computation, and this protocol actually does that. So allows the problem giver to do a single step computation and decide correctly with 100% correctness that which one of them is correct. So which is quite a nice protocol. So when we say malicious, this cloud, it means that it can do anything. It can deviate from the computation in an arbitrary way. Now, there is a second way of looking at this problem. This is proposed by, looked at, analyzed by Belinki et al. And this is where we are not saying the cloud is fully malicious. These clouds or the servers are rational. They want to cut corners, reduce their computation, but they are not, but they want to get their reward. So we talk about the diligence. So this is actually a terminology that is used by Belinki et al. They introduce this a cloud that is diligent, that follows the computation correctly, and lazy. They are cutting corners. They're skipping some computation whenever it's possible. And so they actually showed that you can have, with this model, this is rational model, then you can have security. If you design your fine and bounties and rewards correctly, you can do a game and theoretic analysis to make sure that the result of computation is correct. So this is also provable. So we have two kinds of provable security in cryptographic one and game-based theoretic one. And so if we, I guess this is what we have. If I now, you can see that if I add my smart contract in here, then we effectively, it seems that we should have system with provable security. So there was this system that was proven secure in these two models. If we add a smart contract, this smart contract performs in things computation correctly, so it looks like the whole thing should nicely work together. So let's look at this, one of these in a little bit more detail to see what can go wrong. This is the system by Canati that required malicious, that allowed one cloud to be malicious. Effectively, what they did, if the result that came back from the two clouds they matched, then everything was fine. If they were not matched, they designed a referee protocol that each of these clouds had to commit to the execution trace of their computer, of their computation, and then through a challenge response protocol, the problem giver could find which step of the computation is different between the two, and then perform that step and decide which of the two is correct. And so the whole protocol has provable security if one of the clouds is honest. So this is a very nice, efficient protocol with full information. So that all the messages are over public channel, and then all state information of the problem given is public. So it's really nothing secret. So it can be taken to a smart contract setting. So this is, I think, that it's naturally to use this protocol in a smart contract setting. But now, if we see what happens in a smart contract setting, so the Alice will send the computation to a smart contract. The smart contract send the computation to the cloud. When one cloud replies, the other cloud actually copies the reply and sends back. So this thing actually effectively, this is a copy attack. So by copying the result of the computation of this cloud, because this communication cannot be encrypted because the smart contract, it doesn't have any secret, so there is no secrecy on this one. So this result can be copied, and so this ends up free riding by this malicious cloud and getting paid for the work that they hadn't done. And I think even worse is that because now you have the case that the result of a malicious cloud can be paid without any doing the work, it actually, for a honest cloud, it disincentivizes good behavior. So they will see that there is no need to do the computation. They just randomly send the result and the other one is copied and that's it. So there is no guarantee that the result of computation that we obtain here is correct. So effectively, completely breaks the security of the protocol. So now we have to redesign the protocol. We have to introduce, this is what we did. So we need to have a secure commitment, a two-step opening of the result. And then we have to design this a judge protocol. We have to redesign it and prove security in a universal composability model that allows the protocol to be also run in presence of other protocols, because now we are in the internet setting, and many protocols are run at the same time in the blockchain setting. So our proof should be in universal composability model. So this is what we did. I think because of time, I skipped the details of this, and I think the result can be also extended to the case that we have more than one. We may decide that instead of 2 clouds, we need multiple clouds, because in this case, effectively, what we are aiming for a higher level of security. Here, even if 3 of them collude, it's enough to have 1 cloud that is honest, and that gives us security. And so I think in this case, we can also show that so this collusion is quite a complex, hard thing to protect against. It's a very strong collusion. If you have 4 clouds, 3 of them can collude. So three of them can submit a wrong result that matches. So a majority vote, things like this will not work, because the cloud that is the honest one has only 1 single vote. So we show that you can have a running the 2-party protocol between every pair, and then coming up with a correct decision algorithm, you can obtain security in this setting also. Okay, so this was the malicious setting. So one can, as I said, there were two models for this with provable security. One was malicious setting. This one was the rational adversary that was studied by Belinky et al. And this was the case that the clouds were not malicious, but they were lazy. They deviated from the protocol to save money. So they have a utility function, and they want to maximize the utility function. So what Belinky et al. Did, they showed that if you design this find reward and bounty in a correct way, you can do this kind of game analysis and show that the Nash equilibrium of this game is going to correspond to the case that both of them play diligently. So which means that both clouds are working correctly, and of course, so the result of computation is going to be correct. So it all depends on how your design. So the analysis allows you to design the value of these things correctly so that the result of computation is correct. So this is what they proved. And of course, now we can see that again, this can be taken to a smart contract setting with the same initial thought that this is going to give us a system with provable security. But then again, in this case, we see that the copy attack completely breaks the analysis in this case. And so again, we have to have with the copy attack, you have to have look at the game more carefully. Now it's not only 2 strategies, these clouds, they're going to have different kinds of strategies in their game. So the game becomes more complex. So they can guess, they can copy and then become diligent, they can copy and then become lazy, copy and guess. So we have, and this also to provide security in this setting, we have to design new checking protocols. So even if the results that are submitted, they match, we have to run this match check protocol. And if they do not match, again, you have to run this mismatch check protocol. So becomes the whole design becomes completely, we have to do it from scratch, and is a lot more complex than the case that we do not have a copy of that. And we can, again, we show that if we choose these bounties and the rewards correctly, then the strategy of diligent can give you with the protocol that I just showed, it gives you the diligent as the Nash equilibrium, so you will have the correct computation. Okay, so I think that is that was the 2 examples that in both cases you had provable security, and then and the way that they behaved, it looked that you can naturally take them to a smart contract setting, and in both cases we saw that the protocol fails. And I think and this thing that I said, that this combination doesn't give necessarily security, hopefully now makes sense, that the combination that looked very plausible and secure is not going to work because of all these minute details. So I didn't talk about incentivization in multi-party systems. So I showed you that if you, in the case of cryptographic setting, you can submit to multiple servers and you can have system with provable security. In the case of incentivized system, if you look at rational adversaries, then outsourcing to multiple server becomes a lot more complex. So analysis, game theoretic analysis of collusion becomes a lot, behavior of collusion, colluding people and colluding entities because it becomes a lot more complex. And that's also one of the reasons that we cannot do easily analyze something like TrueBit, which only use incentivization. And I think the other important direction for future work is this efficient implementation of this as protocol. So we have implemented the protocol that I explained in the case of CRR taken to a smart contract setting, but although we have the computation is done off chain, but it is the computation is written in Solidity language because the single step had to be done on the blockchain. So using a more common language like C or C++ for expressing computation, that would be a very nice extension of and moving toward making it more practical. So with that, thank you very much for listening. I put my email here because unfortunately this is a great event, but I cannot stay till the end of it because I have a class. So I have to leave later in the day. If there is any question, please feel free to contact me. Thank you very much.
So for those folks who last year were at the BTS conference, the Blockchain Technology Symposium, this is going to look familiar. Okay, so this is like a variation on that, and it's partly because I haven't really changed my mind right on some of the thoughts I've had, but there's a bit of a variation here, right? So you'll see that if you remember that talk, and you'll see it's a little bit of a critical lens on the application of blockchain, but please accept that in the spirit of what's intended, which is critical reflection. I think it helps us to move forward. Okay, so that's the spirit in which we're approaching this. And you should note that this is really the application of blockchain in the formal sector, right? Here, I'm not talking about crypto assets, cryptocurrencies, and so on. Okay, it's very much in its application in the financial system, typically, which of course is the area that I work in. Well, actually, first of all, just please accept these remarks as mine, not necessarily those of the Bank of Canada. So I'm going to take a little bit of a 101 sort of look at this, kind of quite foundational, right? So it's it's pretty basic stuff, but I think it's worth really recalling some of this. So a little bit like the concept of money, which we take for granted all the time. When we start digging a little bit deeper, things become more complicated, and I think that's the same with this notion of trust, and which in many ways was the beginning point to think about a different conception of trust. And if we start looking a bit deeper and unpack what we mean by trust, the way it's used in a kind of very colloquial, in the kind of common vernacular, if we dig a little bit deeper, what we mean by trust, we typically don't, right? So here I'll just define, maybe a working definition here of trust, which is that we have confidence in the actions of others, whether it's their honesty, their competence, and so on, without actually expecting recourse or oversight. Okay, that's trust. As soon as we have oversight and recourse, you can argue that isn't actually trust because we have some method of sanction. So that without oversight is I think quite important, because with oversight, we're not really trusting. And I'll argue that in our kind of interpersonal interactions, we always have a lot of trust. We have a lot of trust within families, typically, for example, even with friends and so on. But in the commercial world, I would argue that the amount of trust we actually give to our counterparty is actually pretty minimal, right? Most of the time, it's actually we don't actually trust typically our counterparties. even though we often say that we do. What's actually going on, right? We don't trust. It's because we have these mechanisms. Typically we have recourse of some kind. We often take risk, or sometimes we'll take risk, right? Especially if transactions are small and so on. Say, fine, let it go. My losses are small, and just give trust. Or we don't even enter into the transaction at all. So, going back to thinking fundamentally about trust. Well, why do we undertake these interactions if we don't trust a counterparty? And if we follow the route of, in the vernacular, we say, I trust my bank. I may not like my bank, but I trust my bank, right? Because they keep the money and so on. Well, what is it that gives us that confidence? And if we follow the route all the way, we end up finding that typically we end up trusting some kind of sovereign agent, right? Some kind of regulator, typically law enforcement and so on. And going even further, we go all the way to trusting political institutions, right? And, all the way back to sovereign body like Parliament in the case of Canada, for example. So now that doesn't mean that we have to trust those public institutions, and in many ways we don't, right? But there are these accountabilities, but we do rely on them. We do have to rely on them to I think quite a great extent. Okay, so that's kind of this situation, that kind of trust system of trust and reliance that we have. Let's say pre-blockchain, in the before times, right? But then enter blockchain, and there's this promise, right? Which is, well, we don't need to do this, right? With blockchain, we don't need to have that mechanism. We don't need a trust. We don't need any kind of trust. We don't need these recourse mechanisms. No one really has to take risk, because we have this mechanism, blockchain, let's say, and smart contracts put together, that provide all these features, right? They provide this transparency, verifiability of claims, and immutable record, and we don't need this single trusted agent of some kind. I mean, smart contracts, we have this idea of not legally binding commitments, but actually computationally binding, and some would say, that's good enough, right? So this is all great, right? It solves a huge number of problems. Perhaps it introduces all sorts of efficiencies and so on, right? Where we don't need those older structures. So if that's the case, then the question becomes like the Fermi paradox: where is everyone, right? Why don't we have really systems at scale? We have all sorts of experiments around the world. Some actually are quite which actually quite large, and some early implementations. Again, I'm not talking about crypto assets here, right? I'm talking about the formal sector. So this question becomes, right, why don't we see this really at scale? Why don't we see blockchain-based systems really all over the place? And well, many of you are living this, right? So this one comes as a surprise, right? But I'll throw out maybe a few thoughts, a few observations, or even hypotheses, right? Because it has been a long time, right? It's been 8 years since Ethereum was around, and about 13 years since Bitcoin. So here's one, right? We're talking here about really an ecosystem level play. We're not talking about applications. We're not talking about single institutions and so on, right? We're talking about things like the ecosystem, which involve multiple agents, all sorts of people with really different vested interests and so on. So I think one of the things that are often quite difficult is to really find that common value proposition, right, on which you base some kind of endeavor. And often, for example, in banking, these folks are trying to get together and do something in common, but they both compete and they cooperate. And that's often a very difficult balance to achieve. So, you see a lot of these remarks are really what the kind of practical sort of sharp end of things, the reality of how things work in these markets. So especially when many of these experiments are done with large institutions, for example, large FIs and so on, there's all sorts of views, right, within these FIs. And often there's a lot of work in getting very senior level decisions to be made. Within an organization, you'll find different views of all kinds, and pulling them all together sometimes into a common view is very difficult. So one of the things that needs to happen is the decision making within an institution. You could say the governance within institutions to get behind these initiatives. Another thought I had was, what is the role of the public sector here. You know, whenever we have these situations where there are lots of different competing demands, you know, actually this goes back to the mission of BGIN, I think, around governance. What role can the public sector play? Because you could argue that that's ultimately what public agents do, right? There's all sorts of stakeholders in society where they need to perhaps make trade-offs and of all sorts to get things moving, and it's something that public agents do quite well, or at least they're well practiced. Maybe there's a role here, a more explicit role for the public sector to play. Another thought, the hypothesis that actually after our JASPER series of experiments, if you don't know, since 2016 through to about 2019, Bank of Canada with others in the financial system and with others like the Monetary Authority of Singapore did a series of experiments under the name JASPER around the value proposition of blockchain. And one of the, I think, the hanging hypotheses that I'm left with is that it could be that blockchain is really a function of scale. In other words, these experiments that are relatively small don't really show value simply because they can't. And you know, by definition, it's very hard to have a proof of concept at large scale, right? It doesn't, it's not really a proof of concept, you could argue anymore. So this often requires a bit of a leap of faith that most institutions won't make, some will. So my thoughts on this are that in future experiments, future work, we'd really need to be very explicit about a few things, right? That first of all, this isn't about application, it's not about an institution, it's really about an ecosystem, and the value has to be apparent at the level of an ecosystem. So what are the signals maybe in designing experiments in future, endeavors, right? Well, first of all, are we actually looking at a new business model? Or are we just taking the existing business model and simply applying technology to it? My argument would be that fine, if you're looking for a 10% improvement, maybe that's one way of doing it. But if you're looking at something much larger, and why would we be looking at something which is like a 10% improvement? Then we're really talking about new business models of some sort. And I think the other area, I'll admit that in JASPER, this was a problem. There's a problem with measurement, right? Where when we try and measure value, because we have to measure value to be able to convince other stakeholders to, pony up the money and get behind large-scale endeavors. You have to show that value, and making measurements is really hard, right? Sometimes it's simply uncomfortable because think about what we're talking about here, right? Often when we're making changes to business models, there are winners, but there are losers as well. And that's a very uncomfortable place to be in, right? Someone has to be able to say, regardless of the circumstances. So for example, we change business processes. Well, it could be that there are areas of business process that mean that a function of some kind is no longer required, right? It takes some guts, right, to basically say, yeah, we're going to measure that, right? And I think often people shy away from that because it's politically quite difficult to do. So that needs buy-in, it needs senior level support. I think just a offshoot of that is that there needs to be probably a measurements team, serious measurements team that is somehow separate, right, from the build team. And I go back to this, when we think of leap of faith, back to some what's the role of the public sector. I'm not advocating for this, by the way, just a thought. One thing that's interesting about the public sector is that we can often have return on investment time horizons that are much longer than the private sector. Right? We don't have to show a return, say, in 1 year or 2 years, which is quite typical, right, for innovation centers in private institutions. And the other important thing is the lens it has. So public agents have this notion of a public good, which is much broader than typically private firms would have, and it goes beyond their private institution. And if everyone buys into this argument that we are talking about an ecosystem level play, then I think that notion of a public good and measuring it is actually quite important for this to work. We do this all the time when we think about other infrastructures. Physical infrastructures. Here's probably another one that I think many of you may have seen who are involved in these projects, is just the reality of how difficult. So in any large scale, non-trivial system, non-blockchain system, operations and governance are really quite challenged. decentralized operations and governance, I think just brings that to another order of magnitude of complexity, right? So it's really, it's actually really very, very challenging. So one thing I think, I mean, needs to mute. Right? Oh, thank you. In the projects I've certainly seen it, explicitly designing, very efficient decentralized operations and governance tends not to be a design goal, right? It's factored in somewhere, but it's not really an explicit design goal. And it seems to me at this point, it really should be, right? And of course, it should be measured very carefully, right? I think projects where we just see if the technology works, I think we're done with that actually, right? We know in many ways we are now it's about the reality of things like this that can really challenge projects. And the final one, which, maybe people don't want to hear, right, is that I think very often it just doesn't fit, right? The technology just doesn't fit the problem space. Now, when we think about, I think some of you may have heard me talk about this before, in a system, say within an institution, when we think about, okay, what kind of database are we going to use? It's very natural, right, for us to think, okay, so let's think about the information space, let's think about the requirements. Are we talking about information that is naturally tabular, that has to be on the fly, contorted in different ways to give results and so on? Okay, then we might think about applying a relational database. If we're thinking about other problem domains where it's about networks, maybe social networks, then we may be naturally drawn to graph databases, right? Because these have a natural fit, right? There's something about the conception of those technologies that fit the problem space. And the same applies here, right? There's no difference. And of course, the fundamental rationale behind blockchain is a different consumption of this trust and reliance mechanism. And often, and especially I would say when there is a trusted party and you don't want to remove that trusted party, sometimes you might want to, but if you don't want to remove the trusted party, I think a huge amount of the value of blockchain just disappears, right? And I think that's a longer conversation, right? And I think people will happily challenge me on that, which is great. But the argument I always make is that once you have that trusted party, huge amount of value actually disappears. And there are other ways of achieving things like resilience and transparency that don't actually need blockchain. So maybe if there's a misfit, better not to force it. Okay, so I'll make a few remarks around. So the Project Jasper, the projects in Jasper, were really looking at the wholesale environment. But I'll just speak a little bit to how we think about blockchain in the retail space. And we haven't come to actually a firm conclusion here, but I'll give you a sense of what our current thinking is right now. So let's think first about a few of the properties. I mean, there are many properties, of course, and goals of retail CBDC. But here are a few, I think, which are important to the conversation. First of all, there is a legal entity, right? So the central bank, by definition, has to be there. We'll talk about more. I'll talk about more about each of these in just in the upcoming slides. This has to work at scale. So in the case of Canada, we're looking at a minimum of about 1,000 transactions per second, and that's, I can't remember exactly, but there's a very, very back of the envelope calculation, assuming something like 10 or 15 million Canadians go out and buy a sandwich every lunchtime over a 1 hour period, something of that order, just to give an order of magnitude, and we end up with about 1,000 TPS. But when we think about the world of microtransactions, which may or may not appear, now we're talking, well, about times 10, times 100, we really don't know, right? But we know that we have to be ready for that world if we're thinking about CBDC as being 20, 30, 40-year play here. Maybe not out of the gate, right? But somehow we have to rise to that challenge. No system is an island, and CBDC is certainly not an island. So this has to fit with the rest of the digital economy. And there's an interesting question about what if the rest of the digital economy is highly blockchainized, let's say, and there's a really interesting question there. And of course, needless to say, it has to be safe. Everything has to be safe. And our monetary system is, maybe even an order of magnitude more safe, given how much we have to rely on it. So maybe just quickly picking up on each one of these. So right, this question: if you trust the central bank, and by definition, if you're willing to hold a CBDC, you are trusting the central bank. then why do we need a set of independent verifiers other than the central bank? Now, you might argue that, fine, we trust the central bank to be good for the liability, but not necessarily that we're competent to run the system. And that's fair, right? But I would just point out that actually central banks already do. Canada is a bit of a funny one because it's a bit of an outlier in that we don't. Payments Canada runs these systems, but we do. The national critical infrastructure, and they actually run extremely well. It's very, very rare that there are outages, and when there are, they make news. Maybe you don't trust the central bank with ensuring people's privacy, and privacy is actually a policy goal for CBDC in Canada. Anyway. But again, I would argue that blockchain has actually very little to do with privacy. There are all sorts of techniques, being like zero knowledge proofs and so on in the case of Zcash, being employed, but they're not really fundamentally blockchain, I would argue. And then there's this one, which is so some people have made this argument that, okay, fine, you trust the central bank now. We live in a world that's changing. Well, what about 20 years down the road? Right? Do we still continue to trust institutions? And if the answer is no, then I would say blockchain isn't going to help you here, right? Really, then all bets are off, right? That's a very different world, and I know there's a cypherpunk vision of how we can construct society where we don't need this. I don't personally, I don't buy it, right? I think it's totally impractical. Anyway. Second one, is any chance of achieving that kind of scale, right? 1,000 TPS. You might say, okay, fine. Don't use pure blockchain. Think about things like layer 2 solutions to achieve this and so on. And absolutely, there's lots of really good, interesting work going on here. But then the argument is, we're losing the value, right? If we have to put all sorts of band-aids on our approach, then the value of blockchain diminishes. And of course, as we have said, we're continuing to make progress, and that there are improvements. You make compromises, and I still don't know quite how to get around this problem of the reality of the network, which of course will improve, I guess, along with the Metcalfe's law, but it still seems to be a constraint to me. Okay, what about new functions? What about things that we just couldn't do without blockchain? This is interesting, actually. Maybe it lowers barriers to entry for players. Does it do it any more than APIs? I don't know. And it allows programmable contracts. This is actually really interesting and something we're actually working on and investigating. And this little thing I've said here about non-entity based escrow actually interests me, meaning that if we want to use a non-blockchain way of providing programmable contracts, does that mean if you provide an escrow function, does that become a liability, for example, of the central bank? But if we use blockchain and programmable contracts, does it become does the escrow become a binding function of the compute system? In other words, it's actually no one's liability. Right? To me, this is a really interesting question, actually, and it could have some interesting there's interesting ideas there around risks that any entity would have to take. And the last one, skip over this very quickly. Again, why bother with verifying through a whole crowd? Why not use, for example, trusted computing and trusted hardware and so on? And there's an objection. Well, you can't trust the supply chain, which is fair enough. We certainly can't be complacent about that, right? All sorts of issues around supply chain security, but we already do, right? We actually do rely on secure hardware and so on quite heavily. Maybe it's a solvable problem. And then the second question, well, why bother with trusted computing? Is there anything you can gain? There's one thing, right? Possibly, which is offline transfers, which is something we're investigating quite closely. So you can make P2P transfers in the event that the internet is down, or in the case of Canada, a lot of remote areas where there's still poor cellular connectivity. Okay, so just very quickly, so only got a couple of minutes left. Right, there is a continuing search for this value proposition, but I think we just need to be realistic about it. I already mentioned if you're simply applying technology to existing applications and everything else is left the same, I really think it's a waste of time, right? Just not worth the bother. What about existing ecosystems, not applications, ecosystems? Actually, there could be something interesting there, right? The most obvious over-the-counter markets, right, where there isn't really a trusted central party of some kind. There's no exchange, for example, or a depository. That's actually quite interesting, right? Having this idea of a shared ledger, and of course, there's lots of work going on around there. And for us, cross-border, for example, is another interesting one where you have, say two jurisdictions, that the parties in each jurisdiction trust the parties within their jurisdiction, but not overseas. So is blockchain a way of avoiding some kind of trusted intermediary? I think that's still a really interesting question. That's actually being explored by many experiments. At scale, well, I mentioned this already, right? You need this leap of faith, so kind of questionable whether it's even practical, who's willing to make that leap of faith. And of course, new business models, right? That really try to create efficiencies. And I guess you could argue that's the entire play behind DeFi, for example. So interesting work going on there. Okay, that's it. I will stop there.
Okay, thank you very much.
Hello, everyone. Thanks for the invitation to make a presentation today to this group. And I've been enjoying the presentation so far this morning, so it's very informative. Today, I'm going to talk a bit about the digital identity landscape and the Canadian ecosystem. So what we'll share is a bit about the concept of the duty of care and what that means as part of the discussions today in this ecosystem, who we are and what we do as DIACC, what Canadians think from some of our research, a little bit about the Pan-Canadian Trust Framework, what that is and the tool that it provides, and our Trustmark program that is moving forward here in the Canadian ecosystem. So first of all, assurance really matters within this space, and we can see, I can pull so many headlines from breaches. Just this past summer, there was a huge data breach from an internal attack inside of IKEA that affected many customers. And in fact, right now there is a class action lawsuit within Canada that a citizen has leveraged against the federal government of Canada for a breach that occurred during the CERB benefits, during the benefits that were issued for COVID relief during the height of the pandemic. And so one of the things being contemplated in this ecosystem and in that class action lawsuit is actually, did the government owe the citizen a duty of care for their credential that was attacked, to gain that the attackers gain access to their financial information and their finances. So a little bit about who we are. DIACC is a adoption accelerator, and so we work on different projects and research that help to inform strategy and tactics for participants within our ecosystem. And DIACC is also what we call a trust framework provider, and we'll talk a little bit more about that as we go forward, which is to develop an assurance framework and to verify compliance against that framework. We're about 120 member organization. We've been in operation for more than 10 years, and we have different representatives of public and private sector within our ecosystem. Now, I think we've heard it a few times today already. Really, trust is the most valuable commodity, and according to the Edelman's Trust Barometer for 2022, 67% of Canadians fear hackers and cyber attacks, and 47% actually fear losing freedom as a citizen as part of the trust ecosystem related to technology. So trust is paramount in this space. With regard to what Canadians think, well, digital choice is key. And so we've asked Canadians, would they be willing to move to a digital identity approach for digital credentials and so on? And really 8 in 10 were supportive once we explained to them what digital identity was, and that moving to the system would help to redistribute support through the society. Only about 47% really had some understanding of what digital identity meant without assistance. So there's a lot of work and a lot of misunderstandings in this space for sure. But one thing is clear, we did ask Canadians, and we do this research every year, and we're about to do our 4th year of research right now. And this year we have, last year we asked a specific question about, do Canadians want access about them to data that exists in the public and private sector? And overwhelmingly they responded 91% want access to see and use and control that data held by federal and provincial governments, followed closely by 86% in the private sector. So without much education or explanation, Canadians do understand the concept of personal data control, but they don't necessarily understand the words digital identity without some education and support. Canadians are very supportive of the use of digital wallets is increasing, and we saw that 4 in 10 Canadians are using digital wallets of some type. And this use is highest in what we would call the sandwich generation. This is really the generation of what we would call caregivers, people who are caring for both children in the home and perhaps senior adults within their support system as well. And Apple Wallet being the highest among those types of wallets being used, followed by some other wallets and Samsung Apple Pay. So a little bit of the demographics there. So really the concept of a duty of care is the definition of how a person or an organization would be cared for within their services, within their interactions. And that duty of care enables confidence for people and organizations to adopt solutions, to adopt this new paradigm and this new approach. In terms of tools of the trade, I do want to talk a little bit about some of the differences between standards and frameworks. We find this to be a little bit confusing within our ecosystem, and so we've spent some time on education. The standard space we really see as the definition of a methodology. It tends to define a single methodology, and it's often rigid purposely so to have that community focus on a single agreed approach of a single accepted agreed approach of how to do something. So our example here is that our house is defined as walls, a roof, and doors and windows, whereas frameworks is really more about taking a method or methods and putting that into context of different risk profiles and different risk scenarios so that risk can be managed. And so this is more, a framework is more about verifying policy and regulatory outcomes. It's more about defining the definition for a system or ecosystems, and it allows for innovation across different types of methodologies and allows new methodologies to come into existence as well. And so in our example, a house that is, we have our definition standard of a house that's built into an earthquake zone. And so the implementer has to do additional requirements, X, Y, Z, to be ensure that that risk is managed and that security is maintained. Now, this brings us to our Pan-Canadian Trust Framework. And our Pan-Canadian Trust Framework is our definition of a duty of care for Canadians and how they would expect services to treat them. This includes both standards and technology implementation. And this is agnostic for different types of technologies and flexible. This focuses on the rules and regulatory outcomes for an ecosystem and also build confidence for people and organizations for their adoption. So this is a really critical middle layer tool. And so if we look at this a different way, we have our methods and our definitions, which could be standards, industry, national, international, and it could also be open source. So this is our standards and codes defining methodologies. And then we have our trust framework, and this is our duty of care, our verifiable governance, risk, and compliance scheme, which the risk tolerance or the different types of risks are set by the use cases and the communities that are adopting. And so they're really defining those uses. So we are focusing on this middle layer, helping to add that risk management to allow for innovation and verification of trust against for communities that need it against different methodologies. Now, if we look at this, the Pan-Canadian Trust Framework in detail, we've got some informative components, and this really tells us the basis of the definitions and the models and how this works. We've got specified components. So here's where our conformance criteria sits. That is steps through the different levels of assurance or risk profiles that can be adopted and implemented and applied for a service. And you can see that there are distinct types of services here or distinct types of capabilities. And one that's newer for us that we've added is the digital wallet. And from our knowledge, this may be one of the first or the only policy and outcomes-based frameworks approaches to measure the outcome of a digital wallet. So we're not defining the technology, we're defining what does that wallet have for an outcome against different risk profiles. And of course, all of this is encompassed and built with privacy as by design embedded in. to the approach. And now we're developing what we're calling a trust registry component. So this is what are the policy and regulatory outcomes of a registry that would assert trust of a wallet, of a credential, of a different piece within a different capability within the ecosystem. What we see in the Canadian ecosystem is that there's no single solution yet, and really a one-size-fits-all approach doesn't fit at all. And that means a framework is really important to help us to make good decisions for adoption. So if we look at what this means in context, we can take a quick look at our internet dog from the New Yorker cartoon in 1993, where the cartoon says that on the internet, nobody knows that you're a dog. And quite frankly, it's still in that space today in some aspects. So let's look at how a duty of care interplays in different scenarios. A duty of care helps in the platform ecosystem. So in this space where still no one knows that you're a dog, this is where the big technology giants are playing. Certainly works to provide a definition of how a person or an organization should be cared for within an operator network. Now, these networks might not work everywhere, but they do work where we need them most, like our payment systems, our bank accounts, and our mobile phones. The duty of care provides a governance layer and a definition layer for self-sovereign ecosystems, which is especially important where people need to look after their data much like they look after their money. And maybe in this ecosystem, our dog can actually show a credential to prove that it is a dog. And then in the open API ecosystem, we do see a lot of this in the ecosystem today. And this is a space where people don't really remember the connections that they've made. And so the system doesn't know if they're a dog, but they do know that they like to buy doggy treats. And so this type of duty of care is really flexible and can be applied for these 4 different scenarios. There are certainly more scenarios, but these are 4 that we focused on for the purpose of our talk today. Duty of care also helps with different challenges within the ecosystem, particularly around creating market conditions. What we see right now is that there are many standards being developed within the space, and economy-wide and jurisdictional adoption is not necessarily clear. So this is a moving space, and the duty of care provides a layer to verify trust across different standards across the ecosystem while they evolve. A duty of care also helps to inform the regulatory needs. One of the things we see here in Canada is that from a regulatory perspective, the definition of our ability to access and control data, which we saw Canadians want, is not defined by a regulatory, from a regulatory perspective. So we're really at the forefront of regulatory change that would put people in more control of their data, but also to help define accountability models so people are protected, organizations are protected within this ecosystem. It also helps to promote market growth. Particularly, we should be looking at for market growth sustainability. So as we have existing and emerging Web3 distributed ecosystems, it's important to look at sustainability for these ecosystems. How are they being funded? How are they self-funding and sustaining? And personal data exchange responsibility, where that responsibility and accountability sits really needs clarity. And as well as for inclusion within these ecosystems for critical mass, understanding it, making sure that we have adoption, diversity, equitability, and inclusion as we move forward. So really adopting a duty of care supports navigation through a complex ecosystem where we have different paradigms, different models from Web 2 to Web 3, from centralized to distributed, and all of the hybrids in between. So now the next step that we've taken in Canada is to launch what we call the Voila Verify program. This is a third-party conformity assessment trustmark program. This program leverages the PCTF, which is the controls to verify the duty of care for operating a trusted service. And the Voila Verify program is actually the program itself that measures that determination and issues the conformance trustmark. This is really something to help people to reduce fraud, certainly helps solution providers to build more trustworthy solutions and to benchmark themselves. It helps public sector to know which solutions are more trustworthy for adoption. And of course, it helps for the economy to see where we measure up. For us in DIACC, we're focused on the digital economy, so it is a Canadian approach. But that said, it's an international approach that it must be for the digital economy. A snapshot of the program, we are currently accrediting information security auditors, so assessors, technology testing laboratories, readiness advisors to help organizations to prepare and to build their solutions, ultimately verifying services, which includes different types of networks. Certainly has been interesting to see how these how this approach applies to a very distributed self-sovereign network, to a more centralized trusted operator network, and all of the hybrids in between, for example. And then we will have a public registry or a trust registry ourselves of these solutions that have been verified. We do have an oversight board who make sure that we have the right oversight on the program. We have both regional, jurisdictional representatives representing expertise in legal and policy, as well as public sector, with Quebec being strongly represented on this board as well as representatives from around the world with international audit experience, as well as with experience in different types of technology implementations from around the world. So we'll continue to grow this advisory and oversight board as we move forward. So let's look at how self-assessment, what self-assessment is versus third-party conformity assessment. Certainly when we have a lower assurance and lower risk profiles, the ability for a service provider to verify their own qualifications and their own ability to meet the requirements, let's say for level of assurance 1, a low level of assurance, self-assessment will provide sufficient verification. This will be contractually binding because this is a low risk scenario. As we move up into higher levels of assurance, leveraging third-party conformity assessment by an auditor through the certification scheme owner, such as DIACC, our organization, this provides that third-party conformity assessment that really is necessary to verify conformance as we move higher up into the risk scenarios. What this looks like in line is we have a service that comes forward to us. They identify which technical components, which PCTF components their organization is meeting. We do have the ability to select those different capabilities because there are many different ways to build services, and we do find that there are many different organizations are partnering, and it's not very typical that end-to-end a full solution is provided by a single organization. That audit is provided through one of our accredited auditors, and then we provide that accreditation based on that auditor's report and that quality assurance, all to issue a trust mark that is signaling a trusted service through our program. Now, I think for this group as well, what we plan to do as well is to make this trust mark available through a human readable registry, but as we have also as will also be important within this ecosystem going forward, digital wallets will play a role. And so one can imagine that a digital wallet may, perhaps a government may wish to issue a government issued credential only into a digital wallet that has been verified for trust and assurance. Or they may say, to a citizen or to a resident, if you're using your credential through a digital wallet, we really recommend that when you're using that credential, you're only sharing your credential with a service that's been verified as a trusted service. And so not only will we be able to communicate this trust mark through our human readable registry online, but we'll also be able to send this as signals, potentially through verifiable credentials within a wallet or within another type of network signal for the signal that would make the most sense for that network. And so we think this will also be an important signaling to remove complexity from the user and provide them with that layer of protection or that layer of assurance, whether that's a requirement, so the credential can only be shared through that methodology, or whether that's through a strong suggestion as part of a mechanism for protection for that consumer, that citizen, that resident. So looking at how this lines up with ISO accreditation, currently DIACC as an organization we have built this program in a line with ISO approaches, and we are currently going through our ISO accreditation as a certifying body for 17065. And 17065 is including requirements for bodies that are providing audit, bodies that are guiding audit guidelines for auditing and management systems, for those that are providing requirements for operations of various types of bodies, and those general requirements for organizations for the competence of testing laboratories. And finally, for the requirements for organizations that issue requirements for third-party marks of conformity. So by moving forward, we've built an alignment with 17065, and by moving forward with that ISO accreditation, we'll be verifying that, as well as all of the underlying ISO specifications that are feeding into and supporting 17065. So this will help us, of course, to continue to benchmark against what we need for trust within the Canadian ecosystem, and most importantly, what we need in a distributed ecosystem like the global digital economy and operating at scale internationally. Now, if we look at international recognition within the space, we do see already adoption and alignment within works that are happening around the world. So we have built our Pan-Canadian Trust Framework, again, to align with Canadian regulatory constraints, regulatory outcomes and needs. And so for the, and this is very much aligned with the direction of the Australian Digital Identity Trust Framework, also aligned with the NIST 800-63-4 approach for digital identity guidelines. And so we've been staying in step with those approaches from around the world, and with an eye toward the European Union EIDAS, European Wallet Reference Architecture, which is moving forward within the European ecosystem. Now, very specifically, we have been referenced by the Open Identity Exchange as one of the frameworks to look for and look toward for providing value within this this layer of governance and verification as we move through paradigms, from Web 2 to Web 3 to distributed ecosystems. And also we've been referenced directly by the UK Digital Identity Trust and Attributes Framework. So there's a direct reference from an international approach as well. So what we see within this ecosystem is there is continual work that needs to be done to maintain and align from an international approach. And we're just one of those tools to help with that alignment from our approach within the ecosystem. For those of you who'd like to learn more about what we see within the ecosystem in Canada, how the Pan-Canadian Trust Framework provides value, and what we see the trend line being there, please get in touch with us and let us know. I would say that ultimately, some of the focus here is that we don't see a single approach yet in Canada. We have provincial, some provincial approaches. The provinces are the holders of the legal identity verification, those legal constraints, those legal requirements. We have a federal jurisdiction that's taking some of its own views and its own approach. And then we have different economic sectoral players who are taking their approaches as well. And so we have everything within the Canadian ecosystem from open source Hyperledger Indies Aries digital wallet verifiable credentials approach to more, which is more in the provincial space, to the federal government, who is more focused in the W3C verifiable credentials developments happening within the W3C. And then we've got hybrid networks such as the Verify Me network, which is built by a consortium of financial institutions, financial stakeholders, including insurance providers. And that's really a permissioned network. I would call it a kind of a hybrid between a very distributed, self-sovereign distributed network approach to a more permission-based network approach. So in Canada, again, that one-size-fits-all approach doesn't fit at all yet. So we do think that one of the important pieces of the puzzle to help us move forward and make good decisions and transition from Web 2 to Web 3 is a duty of care definition, like a Pan-Canadian Trust Framework. And so we'd love to hear your feedback. We've gotten feedback into the framework from 9 different countries around the world. We always open public review comment periods. And so we love to hear what people say from around the world and feed that knowledge into our framework. I tried to give you back a little bit of your time. I think we were running a little behind. So hopefully I've done that. And if there are questions, or feedback from the audience, I'd be happy to take them if that works for the chair.
Great. So it's hard for me not to be talking too much about FTX, but what I'll do is basically start off by talking about a little bit about the history of big problems in finance. And the takeaway is that this is not the first time a technology has broken or that people have broken either. Then I'm going to talk a little bit about FTX and what we think we know about it and how it fits in with this history. And then talk a little bit about the implications and talk about, clearly this is going to be a catalyst for regulatory responses, but will they be the right responses? And what I want to propose is a way to think about it. And the way to think about it is to say, hey, for any proposed reforms, and they're coming down the line, we know they are, what harms would have been prevented, but also what innovations would have been prevented as well. So the important thing to remember is things can break. If you look at the history of finance, it's the history of bubbles. We've seen over and over again where a new technology comes out, people get really excited. And oftentimes the investors get carried away and the prices can go to levels far beyond what we figured out after the fact made sense. One of the first ones and one of the classic ones was the South Seas bubble. Early 1700s, there'd been many advances in navigation and going across the oceans. It basically opened up global trade to what they called the South Seas, or what we now call the Pacific Ocean, or the South Pacific. And also, there was another great innovation, the joint stock company. And indeed, the joint stock company made it possible to gather resources from a large number of people to fund a venture, like, for example, the South Seas Company. And here we see a graph of the stock price of the South Seas Company. And we basically see what happened to Isaac Newton, who got caught up in that bubble. But when the South Seas Company bubble occurred, it wasn't just one company. There was a whole wave of copycats, a whole wave of, yes, initial public offerings. Many, if not most of them, failed, and some of them were outright fraudulent. But what was the public policy response? Well, England said, ooh, joint stock companies, bad. Stockbroking, bad. So they basically just banned them. The wrong response. And I think it would be the wrong response for us to respond to the current troubles by saying, ban everything. But we can see that this is the knee-jerk reaction that we may be running into. But not only is the history of finance the history of bubbles, it's also the history of new technologies. And these technologies sometimes work really well, and sometimes they've worked really badly. For example, mortgage-backed securities are actually a very good invention. Assuming, of course, you put good mortgages into them, but where you can pool a bunch of mortgage loans, stick them into a pool, and then carve out securities of various qualities out of that pool. Now, if you have good quality product in, you'll have a predictable product out. But as we know in the financial crisis, what happened is people started pooling a lot of loans that were made to people who should not have gotten mortgages in the first place. So that was a technology that worked well for many years until it blew up. The history of finance is also the history of failures. We have lots of experience with bank runs when you have highly leveraged institutions that get into trouble. And whenever you have a lot of leverage, you have a lot of risk. And the history of finance is also the history of fraud. One of the most famous recent ones that came to light in the financial panic was that of Bernie Madoff. Now, Bernie Madoff was a big man on Wall Street. He ran a FINRA registered broker-dealer. FINRA is our big self-regulator. And also on the side, he was running a great big Ponzi scheme where he was pretending to be a money manager and pretending to offer really good rewards. And it turned out to be a complete fraud. And, by some measures, the amount was well over 50 or even $60 billion of alleged fraudulent assets. But financial technologies are not the only technologies that can break in unexpected ways. There once was a bridge over the Tacoma Narrows, just south of you in Vancouver, down in the state of Washington. And it was a suspension bridge, which was fairly new technology at the time. And they called it Galloping Gertie because, whoops, I'm sorry, my slide did not advance the right way. There's my slide on failures, watching a historic bank run and people lining up in line to get their money out because, well, if there's any doubt as to the solvency of a financial institution, you want to be first in line to get your money out. I was speaking last night with a customer of FTX who basically managed to get most of his money out, but unfortunately, the congestion on the Ethereum blockchain meant that he couldn't get it all out in time, so he still had some left behind in FTX. And of course, here's a picture of Bernie Madoff. And here's a picture of Galloping Gertie, the Tacoma Narrows Bridge. And it turns out that if the wind blew at just the right speed, it would excite the bridge to its natural frequency, and it would oscillate to the point where it literally fell apart. Now, do these disasters mean we stop adopting new technology? No, we learn from our disasters and figure out how to harness this useful technology and avoid future disasters. And indeed, we have this financial regulatory cycle that is repeated over and over and over again. Whenever you have any of these disasters or crises, they usually follow the following steps. First, you have something new, some kind of innovation, something that people look at and they go, wow. And people start applying it in a bunch of different areas. And people get carried away. There's often a lot of excess. And then sooner or later, something breaks. You have a crisis. And people say, we got a problem. And then there's some kind of reform to address the problem. And that's the state that we are in now. It is happening as we speak. Indeed, here are some headlines from today about people in Europe saying, hey, we need rules. We got to fix this. We see our Secretary of the Treasury in the US says we need tighter regulation. All right. So we've got the crisis and now we have the response. So that's sort of a quick summary of where we've come from. Let's take a closer look at FTX and try to figure out, well, what do we really know? Now, my disclaimer is this is all based on media reports. And, so we know that the media doesn't always get it right. But we know that Sam Bankman-Fried, poor guy, he was the son of attorneys. That's got to cause some kind of, that's got to do something to people, right? But smart guy, he went to MIT and then he went to Wall Street, worked at a trading firm called Jane Street. And like many people in TradFi, decided to switch to crypto. So in 2017, he and some colleagues founded a hedge fund called Alameda Research, and they basically were doing arbitrage across different crypto exchanges. And they looked at the exchanges they had and that were available at that time, and they said, hey, we can do better. So in 2019, they founded a thing called FTX. Now, does that stand for Futures Exchange? Or does it, as one Twitter post commented, does it mean F the exchanges? Well, you can always trust Twitter, right? Maybe, maybe not. Okay, Well, and as you knew, FTX grew and grew. 2020, they buy out CZ, one of the early investors, for $1 billion allegedly, but he retained a lot of FTX tokens as a result of his exit. And I need to make sure that both of my screens go forward at the same time. So I want to apologize for looking at the wrong screen here. All right, so what do we know about FTX? Well, there's the tweet that I told you about. And then what we see is, yes, July 2021, they raise even more capital at amazing valuations. They become one of the largest crypto exchanges. They create or acquire literally over 100 subsidiaries and affiliates. They acquired other businesses, and they were based in Hong Kong. But in 2021, they moved to the Bahamas. Now, the Bahamas is a very crypto-friendly group of islands in the Caribbean, about 400,000 people total. And they're famous for issuing the very first central bank digital currency. And 2020, they issued the Digital Assets and Registered Exchanges Act, the DARE Act. Very principles-based. Not a lot of rules issued under the act, but basically they tell you things. You have to have appropriate and sufficient systems and controls, blah, blah, blah. Then we have their US entity. Now, this was under a holding company by the name of West Realm Shires, which was a separate affiliate from FTX Global. And notice I put, question marks by affiliate there, because, well, we will see how separately they really were at the end. This is still one of the great unknowns. But they owned a futures exchange in the US that was regulated by the Commodity Futures Trading Commission, and they bought a FINRA registered broker-dealer. So they were basically trying to buy and build their way into the regulated world. Well, but if you look at how they were regulated, on their website, ftx.us, basically said, look, we're regulated. When you click through, what did they tell you? Well, they were regulated as with money transmitting licenses. And in the US, we do something totally crazy. We do too much regulation at the state level. So they basically were registered with 42 different states as money transmitters. So in other words, as far as the regulators were concerned, they were in the same business as Western Union or MoneyGram. But the real question is, are they ring-fenced enough to protect them from FTX Global? I spoke with a former employee recently who actually suspects that they are. We'll find out. And then we have the question of, wow, they own a broker-dealer? Will our Security Investor Protection Corporation get dragged into this? Because they're the outfit that cleaned up the Madoff mess because Madoff had a broker-dealer. We'll see. Speaking of seeing things, in the US, we have this rule called the Customer Protection Rule. Now, this is a rule that was passed after many, many disasters. When a brokerage firm would fail, and in their death throes, customer assets would disappear. Well, this caused problems because if customer assets can disappear, customers are going to be very hesitant to trust financial institutions. So the SEC came out with a rule which basically says, hey, if you're a financial firm, if you're a broker, you can't commingle your assets with the firm's assets. There are very strict rules about what you can do with your customer assets. Now, was there such a rule in the Bahamas? Well, there really aren't any rules other than anti-money laundering. In the years since the DARE Act came out, the commission only put out 23 pages of rules, and they're all only about anti-money laundering. So, but kind of looks like the ring fencing we've seen is working. So there's some hope for folks in Japan and in the US. So there are headlines today that says the Japanese unit of FTX is actually going to be able to give money back to their customers. And that's encouraging. And we see that LedgerX, which was the exchange that FTX bought, actually has $250 million that they will essentially be able to use to help bail out FTX customers. So it looks like there's something that seems to have been working. But oftentimes when you look at past disasters, you'll have disasters in corporate governance as well, where there was a lack of internal checks and controls inside the company. And wow, for Alameda and FTX, they only had one director, SBF himself, until last year. And then they added 2 directors to get a grand total of 3 on the board. Why didn't all of the people who put in hundreds of millions of dollars check out the governance, check out the board, do any due diligence? That's one of the questions. But again, when you look at the great disasters through history, it's the same game all over again. Plus ça change, plus c'est la même chose, as the French have said. If you look at the dot-com bubble, you'll find similar stories of venture capitalists rushing to throw money at the latest dot-com wunderkind and not really paying attention to the basics of, can they run a business? But again, if you look at the FTX US derivatives board, what was formerly LedgerX, FTX put together an all-star board. The chair was the general counsel of the Depository Trust and Clearing Corporation, our primary settlement utility in the US. We had former SEC staffers who were at places like Robinhood, a former CFTC commissioner, and other people who are basically name brand, solid, respectable people. So if you looked at that board, you said, great. You look at the parent company, And at this point, most of you are quite familiar with what happened. So I'll go through this pretty quickly. As you know, the crypto winter brought down many, many firms. We saw the collapse of Terra and Luna. We saw highly leveraged entities like BlockFi and Voyager and Three Arrows Capital collapse. And we saw SBF run in as the rescuer. And indeed, there's a famous tweet from Jim Cramer, who basically said, Sam Bankman-Fried is the new JP Morgan. Because one of the things we saw in previous crises, like the Panic of 1907, JP Morgan and his empire came in and basically rescued the financial system on a number of occasions. The most famous in the Panic of 1907, things were falling apart. JP Morgan brings everybody together and stops the panic. Well, the Sam Bankman-Fried was trying to do that, although the allegations are he didn't really have the money to do it. But during this time, we saw that SBF became a very high-profile person, as indeed the JP Morgan of the industry. Meanwhile, he's making a lot of donations to Democratic candidates. Other FTX executives, including one of my alumni, were donating to the Republicans, and they were pushing for crypto regulation, with a lot of it going to the Commodity Futures Trading Commission. Now, it's a historical accident as to why we have a separate CFTC in the US from the SEC. And the backstory is in the early 1970s, financial futures came in, and Congress was saying, this no longer fits with the Department of Agriculture, because futures were originally agricultural commodities, and it was the Department of Agriculture that regulated them. So Congress was saying, what do we do? And Ray Garrett, who was running the Securities and Exchange Commission at the time, did not want to deal with futures. He thought that they were a mess. And so he actively lobbied Congress, don't give me this mess. So Congress created a separate agency, the Commodity Futures Trading Commission. It is much smaller than the SEC, and it has much fewer resources than the SEC. And it reports to the Agriculture Committee in the US Congress. So in terms of famous disasters, this is probably one of them. And the fact that the senators on the Ag Committee, like the campaign contributions they get from financial services firms that want to lobby them, means they don't want to merge the CFTC and the SEC, even though it would make really good sense. So anyhow, FTX joins the lobbying game. They basically want a regulator that they think is going to be much more lenient to them. Now, along the way, as you well know, they issued a bunch of tokens. Those tokens could be used for discounts on trading fees on the exchange, but their real value came from the fact that FTX promised that periodically they would buy some back and burn them. Now, this looks a whole lot like a stock buyback. This promise to go out and essentially take tokens out of circulation. Well, with a stock buyback, that's a lot like a dividend. You're taking money out of the company, giving it to the shareholders. Here, FTX would be taking money out of FTX and giving it to the token holders. That is going to give that token a lot of equity-like characteristics. Notice I didn't say it was equity. It doesn't have any control rights, but it is a participation in the profits of the company. So this is part of the innovation that we've seen in Tokenville, and just part of the many possible innovations that we can see with this technology. And as you well know, these tokens had a lot of value. They were selling for around $25 each until they plummeted. And last time I checked, they were selling for about $1, which mystifies me. Now, we don't know exactly what happened, but it's pretty clear that Alameda either spent or lost a ton of money in the crypto winter. Many of their assets were these illiquid venture capital deals or bailouts that SBF had engineered. So they needed money. Where did they get it from? They got it from Alameda. And Alameda lent them money with FTX tokens as collateral. Well, coming up on November 2nd, CoinDesk reports the FTX balance sheet. And they point out that much of it was in their own tokens. Well now, Cheng-Jung Zhao, who owned a big pile of those tokens, says, I'm out of here. And he puts out a public tweet saying, I'm selling all my tokens. Now, was this an attempt to actually crash a competitor? Or was it a way to do what we call sunshine trading, to let people know what's happening so that you can have a more orderly exit? I don't know. But it set off a run on FTX, just like those bank runs from the days of old. And FTX, after 2 days, basically said, hey, we can't do anything. They were suspending redemptions. And then CZ comes into the rescue. I'll buy them. Signs a non-binding letter of intent, then takes one look at the financials and the mess and says, nope, just kidding, folks. I'm not going to touch it. They abandoned the offer on the 9th. On the 10th, Bahamas puts them into liquidation. And on the 11th, they file for a US bankruptcy. And then 2 days later, they report, we've been hacked. Or were they? Or was it just Bahamian liquidators grabbing the assets for safekeeping? Don't know. Now, so where are we now? Clearly, FTX Global is going through the Bahamas liquidation process. FTX US, also known as West Realm Shires, nice name, is in a US Chapter 11. And so we see this turf battle between the US and the Bahamian bankruptcy processes. So this will keep the lawyers fully employed for a decade at least. And if you want to look at the docket, I can actually put the link in the chat window for you. Well, I'll do that later. So what are the implications? Where are we going from here? Okay. Well, let's take a step back. You think of all those reasons that things broke in the first place. Well, because of that long history, there's some really good reasons why we regulate financial services. You know, as consumers, we want to be protected. I want to make sure that money is not being stolen from my wallet. We want to make sure that people aren't selling us fraudulent goods. If we trust somebody, if we trust an intermediary, we want to make sure that they're not going to collapse on us, because we don't really have, as consumers, enough information to really monitor them. So we depend on the regulators to make sure that they're safe. We want to make sure that, you know, the hucksters aren't, you know, abusing the selling process, that the products aren't really predatory, that will do nasty things to us. It's more controversial, but a lot of people want to be protected from their own ignorance or recklessness. Now, we all want to make sure that the economy is stable and, better yet, grows, and that requires capital formation. Governments don't want criminals using their system so that we get anti-money laundering goals. And again, this is more controversial, but people want to achieve other goals like environmental, social, or governance goals, you know, with financial regulation. So that's why we regulate this stuff. But one point I would like to make is different technology requires different regulation. In New York City, for example, taxis are required to have meters to calculate the fare, and they're required to have a bulletproof shield to protect the drivers from people with guns who want to rob them. But if you look at how technology has changed, well, Uber and Lyft don't need those. The driver has no cash, so there's no robbery risk here. And the fare is known in advance. So you don't need a meter because you already know the fare. So you don't need the same regulations for ride-sharing services as you do for taxis. So just to try to fit old regulation, rather new technology into old regulation, well, there's a saying, you don't put new wine into old wineskins either. So when we think about, you know, how to deal with this situation, we want to be thinking about what is different about this new technology. A lot of us are familiar with the old technology and the old regulation. And what's different about digital assets? Well, for one thing, we've created digital bearer assets. Now, in the old days, and let me give you an example. Okay, this bond is a bearer bond, all right? Okay, so again, this gets to the history of disasters here. So this bearer bond, anybody with their physical hands on the bond is deemed to be the owner of the bond. And in the old days, the way you got paid, the coupons on the bonds is literally you would clip this thing and present it to get paid. Now, speaking of disasters, yeah, this is a railroad that went bankrupt. That there are a lot of those. Now, paper assets are very inefficient. A lot of issues there. And as an industry, we worked really hard to get rid of all the paper. But there's an advantage to having a digital bearer asset that is instantly transferable around the clock, around the world at a negligible cost. That's an amazing invention. We do it with the transparent ledger, and we can make these things programmable. That's even better. And furthermore, we're rethinking the infrastructure. This is based on protocols rather than institutions. Now, I don't need to tell this audience about the tremendous potential that we have, but we want to make sure that whatever we do with our new technology, that we allow it to achieve its potential. But there are a lot of things that are the same, and we need to be very aware of this when we talk about how we're going to regulate the situation, how we're going to govern it. Now, tokenizing assets, that's not new. We've been tokenizing assets for over 400 years. This stock certificate is just a token of ownership. And you know what? What matters is the economic substance that that token represents. In this case, it's yet another bankrupt railroad. But just like in the past, where we've had lots of issues with fraudulent companies, all the way back to the South Seas bubble, various other booms and busts, what have we seen happening? We've seen a lot of fraud. So there are always going to be incentives for bad people to commit fraud. And that's not going away. And so we need to find some way to keep the fraudsters from ruining the industry. There are always going to be some kind of intermediaries. Yes, not your keys, not your crypto, but not everybody really wants to take on cybersecurity personally. A lot of people are going to want to trust somebody who can do it better than they can. We're going to have to worry about not just institutional intermediaries, but we're also going to have to worry about virtual intermediaries like software wallets. How do we know we can trust that wallet? What about systemic risk? And we want to make sure the economy is not going to fail. And we've seen the TradFi economy collapse over and over again. And we want to make sure that a digital economy doesn't have the same problems with highly interconnected and leveraged entities. So to a certain extent, the current problems are doing us a favor by actually identifying where the problems are and giving us a chance to fix it before this technology becomes more widespread. And of course, we're still going to have profit-motivated entities selling financial services with all the conflicts of interest. But so where do we go from here? We can learn from history, and we know that from history that crisis is a catalyst for reform. The regulators and the politicians are going to be running around, we've got to do something, but we've got to be careful to make sure that it is thoughtful, that it makes sense and understands the technological differences between the new and the old technology. And it's not just a knee-jerk reaction like we saw back in the 1700s of like, ooh, ban joint stock companies, ban crypto. No, what we need to do is we need a regulatory infrastructure that understands the technology, that understands the potential, that has the legal authority and the resources to do it right. Putting it all in an underfunded, small, tiny regulator, probably not the best idea. We need to have functional regulation. And I think we should not do what El Salvador is about to do with their new regulators, have a special commission. No, you need somebody with experience in regulating issuers and intermediaries, because that's the key skill that's needed here. But again, I think there's a very useful thought experiment for any reform we want to think about. How would things have worked out differently with a proposed reform? Would that actually solve the problem we're dealing with? But we have to weigh costs versus benefits. What innovations would not have occurred? Sure, we can just ban everything, but then we lose all the potential in this new technology. So we have to ask questions like, wow, if the FAA were here today, could the Wright brothers have gotten permission to launch their first airplane? So when we talk about token issuer regulation, if you look at the DARE Act in the Bahamas, well, they have a little bit of regulation of token issuers, but we have to be careful that we don't just take the TradFi system, which was developed in the days before even long-distance telephones, let alone the internet, and has been fine-tuned for mega corporations, not startups. We have to ask ourselves, so how much can we trust the internet and blockchain-based transparency to replace things like audits? But here's a thought experiment. Could the Ethereum ICO, the original ICO, have taken place under any proposed new regulatory scheme? Or would compliance have been so slow and so expensive that it never would have gotten off the ground? I think most of us would agree that, yeah, we want Ethereum to get off the ground and fly. We want the next Ethereum, whatever that is, to get off the ground and fly. And we need to make sure that we can raise the capital to make that happen while we're protecting investors from the fraudsters. So we also need to think about the intermediaries. Yeah, we need rules, but we also need enforcement. We need people to actually go in and audit these things. But you know what? In the US, it wasn't until after the Madoff scandal, in which they discovered that this guy was running an asset manager and nobody was checking to make sure the assets were actually there. And so again, looking at the Bahamian legislation, it's very nice and principles based, but no real rules to flesh out the regulations. But again, when we think about virtual intermediaries like wallets and DEXs and so forth, we need different tools for them. And what about DeFi? Is it even possible to regulate a DApp? Well, yeah. As always, you need to follow the money, or in this case, the governance tokens. When you look hard at virtually every DApp, there's some degree of centralization. Some group of core developers, somebody holds some administrative key, somebody's holding onto governance tokens, and we need to come up with the right level of required disclosure, inspections, and corporate governance rules. I'm out of time, but we don't, I could have also spent another half hour, an hour talking about corporate governance issues and some of the great disasters there. The reason why we have thousands of pages of corporate law is because we've had plenty of disasters. But with that, I'd like to point out that the digital world is experiencing a lot of the same issues that we've experienced in the TradFi world over and over. Our technology is different, and that means it needs different regulation. But it does need some appropriate regulation. But we have to consider the costs and the benefits of that regulation. We can't just blindly apply the old stuff, the old wineskin to the new wine. Instead, we have to ask ourselves, hey, what harms and what innovations would be prevented by any proposed regulation? So I'm going to be real curious to hear what the rest of you think and what you propose. And with that, I will turn it back over to Matsuo Sensei.
Okay, I would like to move to that panel discussion that at the chat screen, Brian Byrne type in that several questions. Okay, I would like to ask Brian to elaborate your question first.
Hi, Jim. My question is, can you hear me?
Yes, loud and clear.
All right. My question is, what do you think of the proposal lately raised by CZ of Binance by asking to the proof of reserve or even for the proof of liability in light of the collapse of the FTX and some of the other CeFi centralized exchange like Celsius and Voyager? And can the public blockchain be part of the tools being adopted by the regulators in terms of transparency to prove those in terms of a proof of reserve and assets and stuff? I'd like to have some of your thoughts on that.
Clearly, there needs to be some way to assure people that the assets are there and are safe. Now, the TradFi approach is to send in an army of regulators and the army of regulators checks out your paperwork, your policies and procedures, to make sure that, yes, you actually have policies to protect your customers' assets, and they'll check with the auditors, and periodically the auditors will check the assets, they'll check with the bank and say, yes, it's there. Now, the beauty of blockchain is you can see the UTXOs that are associated with any address. So theoretically, from the 30,000 foot level, it sounds really simple to just say, well, just tell us the addresses you have and we'll be able to see that the assets are really there. Well, there can be some security issues there that even though you're guarding your private keys, if the public key is well known, and some of them are, does that provide a bigger venue of attack for the hackers? I can see how some people might argue that, but having a thing where you can rely on the public blockchain, I think, is something that anybody can verify, and there's a lot to be said for that. Now, there can also be some technical issues because, well, you'll have a lot of assets flowing in and out in any given day. And so how do you make sure that you have segregated those assets? Because Bitcoins are fungible. And how do you make sure that these assets are put aside for customers and these are part of the company's assets? But I like the idea of there being some kind of mechanism. To me, it seems like, yeah, why not just tell us the public addresses? But I'd like to hear what the other panelists have to say as well, because I know there are a lot of people on this conference who understand the technology far better than I do.
Thank you.
Okay, before I would like to go to the panel discussion, is there any other question for the that keynote speech? But okay.
Thank you for that. Can you hear me? So my question is, should we be abstracting from creating a registry of, let's say, like token mapping as opposed to a smart contract mapping? It seems that we're focusing a lot on the application and beyond that, as opposed to the fundamentals. Is there validity in saying that we should be mapping out smart contracts and obviously the functionality that we should and should not be using within these programmable contracts? Question to the entire panel.
Actually, I'm not really sure I understand the question. Did you mean effectively that we put limits on the use of smart contracts?
So within the smart contract, the functionalities are generally preset. We have standards already through like EIPs and ERCs. Is there validity in saying that we should have something similar, but from a regulatory point of view?
Yeah, I mean, that's a very interesting question. I think I remember a few years ago some of this discussion, right, around essentially taking some aspects of RegTech, right, and seeing if you can provide a kind of a set of computational guardrails, right, to make sure. It's an interesting question. Frankly, I remember this being discussed years ago, and I haven't actually heard any conversation about it recently. And not that I'm paying close attention to this stuff, but it's an interesting idea. I mean, there's a couple of things. So I think one thing that's a problem, and James has far more expertise on this, right, is what is the extent to which regulation can really be codified in code, right? I mean, of course, there are some things, there's some very simple limits and so on, right? But I guess there's a lot of subtlety in regulations that you could argue don't lend themselves well or without incredible complexity to being computationally bound. So I'm not sure. There's two questions. Well, one is the practicality of it. That I don't know because I don't know enough about the regulatory side. But I suppose the other one is, is that something that regulators even want to get involved in? Because then there's an interesting question about liabilities, right? So suppose the regulators want to provide that guardrail, and it's broken, and things always break, right? Whose liability then is it, right? So it becomes, right? It's kind of, it's almost like, regulations now. I think they're generally designed in a way that there's sanction after the event. And here what we're talking about is flipping that, right? To say that you're providing kind of solid guardrails up front, right? And that probably changes the balance, right, of where liabilities are. I don't know, James probably has something more intelligent to say actually on that. It's an interesting question.
In regulation, there is a trade-off between so-called principles-based regulation and rules-based regulation. In that, now, if you think of software as law, having something very precise and well specified basically makes it easy for compliance officers to say, yes, we're compliant with the rules. However, very precise rules also provide very precise guidelines for people who want to do bad things. And so, and people complain about over precise rules that are no longer relevant, and that that there's very little flexibility for doing things that may make more common sense. So, a lot of practitioners will say, oh, we want principles-based regulation that makes common sense. But then when the regulators come out with some kind of statement, then they say, okay, tell us the details, because we want to make sure that we're in compliance. So there's this tension between principles and rules, or I should say between principles and precision, that is really not going to go away. And that's why we're stuck with this regulation by enforcement that we all complain about in the industry. That something new comes out, and the regulations, the law in the US basically says any kind of fraud is bad. And then we leave it up to the courts to figure out what fraud actually is. And unfortunately, that's the approach used in the US to kind of go after things that the regulators think are bad and hope that the courts back them up. We would all love to have much more precision and clarity coming from our regulators.
Okay. So any other question or comment from the
I have a question to James. Thank you very much for a very interesting presentation. One of the important characteristics of digital assets would be its global nature or cross-border nature. But on the other hand, financial regulations have been designed and enforced at the national level. And my question is, do you have any ideas on the possible reforms to address this gap between the national regulation and the international nature of digital assets?
Oh, that is the major challenge in financial regulation. That national regulators have a large amount of power within their jurisdiction and very little outside. And the fraudsters are very good at jumping across borders and going to places where the regulation is the least stringent. I don't have any magic. I don't have any magic cures for that problem, but it is the biggest challenge right now in regulation. Regulators attempt to work together with each other. They work together through organizations like IOSCO, the International Organization of Securities Commissioners, and various other global standard setters. So you'll notice, again, if you look at the Bahamian legislation, they said that they benchmarked it across countries all over the planet to sort of get basically world-class standards for what they were doing, and that we will see whether how that works out in practice. But other than cooperation among regulators, I wish there were a technological solution. And unfortunately, the only technology solutions I can think of are pretty Orwellian. Things like regulators, putting the great firewall of censorship around their jurisdiction. And I don't think anybody wants to go there.
Okay, thank you very much. And other question?
Hello, do you hear me? Yep. So this is a question potentially for both Joni and the gentleman from the central bank. So Joni mentioned that there is no solution that fits, one solution that fits all the size. And maybe there'll be different kinds of blockchains or different kinds of systems for different scenarios. And I wonder how these heterogeneous systems will play with each other. For example, there might be a pure blockchain layer 1 for at a certain level. There can be some layer 2 at smaller levels, or there might even be hierarchy among the levels. Then I feel this is a pretty complicated system. And I am a bit concerned about the security and both security and performance issues. So I wonder what is the view of DIACC and Central Bank of Canada towards this scenario. There isn't going to be one blockchain that can handle everything for the entire nation of Canada. There must be some heterogeneous system. And what is the perspective of the government and the council?
Okay, thank you for the question, Joni.
Thank you. I think part of what we were communicating is that we don't see a single solution yet. So it may come out that there may be a single solution, excuse me, adopted for the Canadian ecosystem. We don't see that yet. So what we're trying to do is strategize in a way that allows adoption of systems of different, whether that's different types of blockchain, different types of networks, adoption of those networks that work best for that community, for the types of use cases that they're trying to solve. Because the other challenge, yes, it does sound very complex to have more than one type of system, more than one type of network. However, we also don't want to wait so long until there is waiting for the singular network or the singular solution will make us very behind and very delayed in terms of adopting and learning and iterating and evolving. So what we're seeing is that tools that are like our tool, the framework tool, that is part of a suite of tools, maybe sometimes moving a little bit faster than regulation, are important tools to help organizations, to help communities to decide, okay, they want to adopt this type of blockchain network for this type of use case that they need to do, so that they can make those adoptions today and that they can have defined protections, defined accountability today, while there may be a time in the future in Canada where there is a more ubiquitous singular network. Part of the challenge, I think, in Canada as well is that, in many places are like this, but we do have a distributed governance. And so the authority is distributed between provinces and federal government. Depending on if you're talking about finance, then we have federal authority, but the businesses or the people are typically instantiated within the provinces. So it's an intersection of federal regulation and distributed provincial regulation. So I think part of that reflects into that it makes it difficult for us to have a singular, an easily singular pathway forward, because there are different communities and those communities do have the ability to move a bit at their own pace. So I think that in terms of so we want to be able to adopt things now while we can see how the market behaves and if there will be a gravitation toward a singular approach, where the things like a framework and then frameworks as an early entrant, and then more solid regulations. And I love what James was saying, the principles versus the precision, that we see the same in the digital identity space and that regulatory approach. Something like these tools enable us to measure network or credential A and network or credential B, which might be using two different technology protocols, but we can measure the trust that they're providing, and we can determine if their trust is equal. And so if we can determine that their trust through cybersecurity, through proofing, validation, evidence, If we can determine that their trust is the same, then we can discuss the technical capabilities of how information could be transmitted or trusted between two systems. But if we could have two systems that could communicate technologically, but we didn't have the same measured trust of those two systems, then we would really have big risks of moving more trusted information to a less secure ecosystem and less secure information to a more trusted ecosystem. So it is complex, and what we're trying to do is provide some tools to allow some approaches to be adopted so we can test and iterate and then determine which will prevail. And then there may be a time when there may be a more singular approach, but we're not there yet today.
Yeah, actually, I'm not sure how much more I'll add to actually what Joni said. I will say, first of all, that I'll speak on my behalf. Okay, not Bank of Canada, right? Just to put that in there. But yeah, I mean, if you were to, let's say start all over again, right? You tear up the entire system and you decide, okay, we're going to start from scratch. Maybe you could conceive of a single system. You rule them all with a single ledger or single protocol. But even if it could do that, I'm not sure if it would be a good idea anyway, right? Because if we think about really complex systems, we typically there isn't a single system. It's more that there's a system of systems, right? And because we have different parts of a large complex system, where we have to have specializations and certain kind of functions that have to be more advanced in one area, less advanced in another, and so on, right? So I think typically, I mean, if you think about organic systems, and I would argue that that's realistically how something like this would grow organically anyway, right? That's where we end up. We end up with specializations in various areas, but there's still an interconnection between those, right? So if we assume that's the world we'll grow up in, because there's different needs in different jurisdictions, there's different needs for different types of instruments and assets and so on. In particular, in fact, I was going to say blockchain, but let's think even more broadly than blockchain, even centralized systems and so on, right? The trick seems to be some of the things that Joni mentioned around what are the kind of principles and practices that govern this system of systems as a whole, but also at a more technological level, what are the interconnecting protocols, right? How do we develop these in a way that they can really accomplish communications and safety and performance and all these things, and support safety, right, and governance and so on. It's obviously a really difficult challenge. We know that there are various protocols that people have proposed, but I think there's probably a lot more work to be done. And frankly, we can take examples. I mean, as I'm sure many people in the room already do, of internet protocols, right? We think about the way SMTP works, for example, works incredibly well, right? There's an example where you have very, very in systems themselves, very different ways of dealing with email. But what's key is that the protocol in between these works really well, right? And I think that's probably the challenge is. But I think, thinking about a single system to rule them all, I suspect is, well, one is, I don't think it's a practical starting point anyway, but I also don't think it's a good idea, actually, if we think about complex systems, right, and the way you need to really design those.
So any other question and the discussion from audience? So if we have some question from remote audience, so please type in that question or some comments in the chat screen, or raise your hand. But also during waiting that kind of additional question, I would like to ask one question. That I would like to double click the keywords provided by Joni. This is a duty of care. So this is an important concept, I think, because that Bitcoin is originally aimed to create that the world without any trusted third party, but in reality, we need some level of trusted party to create a social system based on blockchain. And so after seeing that recent happening around the FTX or exchange, so we need to have the common understanding common understanding again about what blockchain achieved, what blockchain do not provide. And yeah, so if we agree that the blockchain cannot provide so fully 100% fully decentralized world, so we need to think about that the duty of care by stakeholders. And I would like to ask all panelists the question about that. What is the core value of the blockchain, or true value of the blockchain, in the sense of the decentralization over distributing the duty of care? So, Joni, so can you answer my question first?
Yes, thank you. I think it's a good question. We developed the trust framework as a governance risk compliance scheme, and only when we provided it to legal counsel to give us a review on the type to validate the liability protections, the type of protections it was providing, counsel told us that we actually have a legal tool called a duty of care. And so we thought this is a wonderful opportunity, because these are simple words in the English language that can mean things to people emotionally. You have a duty of care. You're being cared for in some way. One of the things that we're working through within our ecosystem, as well, is how to do assessment of different kinds of networks. When if you have a trusted operator network or a traditional federated network, it's very clear about a singular set of rules and a singular set of expectations, and usually you'd have to agree to those rules to be a part of that network. That's part of the entry for that network. And so in the more traditional types of networks that have that centralized approach to the rule making and to the accountability model, it's very clear. And so one of the things that we're working through is how do we then assess when it's in a very distributed ecosystem, and actually it would almost be impossible to go to every node, every entity in a completely distributed, unpermissioned ecosystem and provide that kind of a verification. So what does verification mean? What does trust mean? What does that look like in that kind of an ecosystem? So I think, we see different types of bodies, at least within the types of networks within the digital identity ecosystem that I'm working in, that intersects finance and intersects other types of assets. We do see certain kind of communities, and so self-sovereign identity communities, self-sovereign networks is one. Trust over IP community is another, who are creating these kinds of networks. And so that's one thing that we are working to understand, is setting the right expectation and communication and education around the duty of care, because part of the distributed network and part of the pushing of empowerment for people to be able to make these kinds of transactions and to be able to participate in these ecosystems, it also puts a certain responsibility. They are now taking new accountability that they haven't taken before. And so what does that mean in a very distributed and unpermissioned type of blockchain network? So I think it's a very good question, and one that we're working through with our stakeholders right now. And what we've come down to is this approach to put forward this kind of a definition, and then different actors within that ecosystem can become verified, and then they can send signals that they are verified. But then there is a certain set of each actor also setting its own rules about, okay, will I only trust something that sends a verified signal, or will I maybe trust something that's not sending a verified signal, but I know that there's maybe more risk with that. So it's a complicated question, and one that we're working through, and I'm very curious to hear what the other panelists think about how to strategize this.
Okay, thank you very much. So I would like to ask one more question to Joni on that. So this is I think a future research topic, but is there any formal method or formal methodology to analyze the structure of the duty of care
Yeah. So the formalized method that we're working through is a standards-based approach in line with one would expect for the type of aligned with ISO type standards development. So we're taking a standards-based approach using technical and subject matter policy-based business processes, societal community experts to provide feedback and guidance into that process, into the framework as we develop the framework. So we are taking that type of a peer review, ISO aligned, standards based approach to the work that we're doing. It's very iterative. I would say that it is also something that is very it's very ripe, very approachable for a more deep academia type, an academic type of higher education research project, multiple projects, because I think we really are talking about how a shift in society, but I also like the FTX discussion, which really talked about how we've done this before and we'll do it again. And so we kind of keep going through these patterns. So I think part of it is recognizing these patterns and seeing where they exist. But I think it would be a great topic for deeper research among professional communities, academia communities, and others who have interest in the topics.
Thank you very much. And so we are running out of time, but James, and so do you have some, okay, but before that, okay, let us have that 3 more minutes to extend this discussion. But so I found one hand raised. So Emiliano, so could you ask some questions?
Hi, could you hear me?
Yep.
Yes, so first of all, thank you very much for all the insight that you are providing us. It's really super interesting, and definitely I'm taking some of the Joni. That was this one solution doesn't fit for all, and everything that Professor Angel said about the FTX. So I was for a case, one of the people affected by the Celsius case, and I was affected by the Celsius case for the simple reason that I trust a bank, so a completely different kind of service that was putting these funds for getting the yield with them. And in Germany, that was supposed to be like the unique way to get to Celsius access, because there was no chance to get to Celsius in there. And this leads me to a couple of questions. So the first one is, I don't need to trust anybody to transact with Bitcoin because I trust the code that is inside the cryptocurrency. So I don't need to have any external sources that is telling me that this is working because I have the entire network doing that for me. So do you think that this kind of regulation that we're talking about, the searching that we are doing into that, it's something that is needed at this moment of transition towards, I don't know, regular web to Web3 or from TradFi to DeFi, and it will need some transitional kinds of rules that will define then after how the new, what Joni was saying, how the new world will be, or there is something that we need to bring from our traditional world right now, because it, as Joni said, it's happening and it's going to happen again. Also, when we have some regulator shield and token that says, oh, this is trusted as it should be.
Okay, so anyone who can answer that?
I think you're bringing up some interesting points here. Now, the decentralization is sort of, I view it as the Platonic ideal that Satoshi has given us here. And I think that in any human environment, you know, even in Bitcoin, you find humans involved at various stages. And so whenever you have humans involved, there are going to be problems because, you know, we are messy organisms. And you might think, oh, I've got Bitcoin and I don't have to trust an institution, but well, are you custody? You know, do you have your own keys? Oh, okay. Oh, you have your keys. They're sitting in a software wallet, right? You know, did you code that wallet yourself? That you know, so you know, there's a level of trust, you know, in the protocol, and we have good reasons why it has achieved that level of trust. But there's always going to be, you know, humans involved, and that means we're going to need, you know, some kind of ways of dealing with the problems that we messy humans bring to the system.
Yes, I definitely agree on the fact that I can build my own trust, and that's why this kind of environment is do your own research and do your own protection. And I can trust myself for what I can do it, but definitely I cannot be defended by a hacker that has an evil intention. But definitely the fact that it will be an external organs or someone that is telling me that this is protected, it's probably as Jim is saying, that it's something because we are human, we are fallible, and so we can do mistakes because we have this kind of inclination. But yes, thank you for taking the question.
Thank you very much. We are running out of time, and so I would like to say one thing. And so in the original Satoshi Nakamoto's paper, no sentence contained the word of decentralization. Yeah, that is an interesting thing, and I think that we need to go back to the original, the theoretical discussion of on the duty of care or level of decentralization, something like that, to understand what blockchain provides, what blockchain doesn't provide. It should be that future research topic, and it should be that future work item to begin. Anyway, thank you very much for joining for a long morning session, and I hope that discussion help everyone to think about the future of blockchain. Thank you very much. And the afternoon session will start at 2 p.m. in Pacific time. Thank you very much for joining, and have a great day ahead.